So the way that I had originally planned this video was to follow the journey of my printer, which is obsolete and broken, as it travels around Sydney, finding out why it was designed that way and how it's disposed of. But for those of you who don't know, it's March and April of 2020, and currently there's a pandemic on, which means we can't go outside and follow this journey in the real world. So we're going to do it digitally. Before we begin this journey, we need to have some definitions in mind. First of all, electronic waste. It's anything that's discarded or used that involves electronics, and it can be resalvaged, reused, resold, or simply disposed of. Laptops, TVs, and hard disks are all examples of e-waste. In fact, in 1 year alone, Australia will produce almost 50 million tonnes of e-waste. The disposal of this e-waste causes a huge environmental problem, but also it's a lost resource. Whilst dominated by metals such as iron, copper and aluminium, it's really the smaller trace amounts of copper, silver, gold, palladium, iridium and other rare earth metals. This is a huge resource which can either be made into new items or sold on into other uses. But the typical process of producing the waste in developed countries like Australia and USA before shipping it off to developed nations in Southeast Asia and the Asian continent has some serious ethical dilemmas associated with it. On the one hand, the processing of this waste is a huge industry, generating almost $42 billion in 2019, and that's growing to over $100 billion in 2027. So it generates income and supports the livelihoods of a vast number of people. This is a good thing, right? When you dig a little deeper, you find out that there are some really large negative side effects. According to the WHO, e-waste can lead to exposure to cadmium, chromium, bromium, and other PCBs. These chemicals are toxic and they accumulate in the soil, water, and food. Children in communities that e-waste is produced are particularly vulnerable. Exposure to such toxic chemicals at a young age can damage their immune, central nervous systems, digestive systems, and reproductive systems. According to one study examining the health impacts in towns where e-waste is produced and processed, this led to a decrease in thyroid function, a decrease in lung function, and an increase in the incidence of stillbirths and birth complications. Clearly, there's an imbalance here. Those that produce the e-waste and those that are most affected by the e-waste live in two very different places. Beyond health consequences, there's some serious environmental impacts to consider. In 2017, the UN estimated that 50 million tonnes of e-waste would be dumped in the third world. This is essentially landfill. This informal processing of waste is an environmental nightmare. In an informal setting, when this waste is processed, it's burnt and turned into an aerosol. These aerosols have the ability to spread across vast areas, impacting millions. In fact, one study found that from one town in India that processed e-waste, it went on to infect almost 45 million people. The aerosols spread through the natural wind, entering our environment and passing through the food-soil barrier. This completes the cycle and brings it back, impacting the health of millions of people. These far-reaching health and environmental consequences stretch beyond the original boundaries of where the waste was produced and where it was processed, and we can see how many people this would impact across the world. But what about the ethics? Where does society, the government, and people come into all this? Well, if we look at it from several ethical perspectives, we can find some new insight. Crucially, we can find out how engineers intersect in all this. According to Engineers Australia, engineers strive to use their knowledge and skills to benefit the community and come up with engineering solutions for a sustainable future. And engineers have the right to come up with such creative solutions however they see fit. They have the right to express their free will through those designs. As a trusted profession, engineering also has a lot of responsibilities. Crucially, Engineers Australia's Code of Ethics, Section 4, is all about sustainability. They have to be informed and inform others about the consequences of their activities, be considerate of the health, safety and environmental and economic considerations of an engineering task, and crucially, balance the current needs with that of the future generations. There's also an argument for utilitarianism, an ethical theory that determines right from wrong by focusing on outcomes. Essentially, what does the most good is the most ethical choice. And from this perspective, we can see that not only does e-waste cause a lot of bad or unhappiness to people's health and the environment, but there's also a huge resource that goes untapped. The minerals recovered from e-waste annually, according to Monash University, is worth over $62 billion US. So, there's a lot of good that goes untapped with e-waste. If we change perspectives for a bit, we can see that the role of society and individuals in this as well. Consumers, as both individuals and members of society, have a huge role to play. A virtue that consumers strive for, and the society strives to meet, is to have the needs of the consumer met by society. But we see how this often extends to their wants as well. They have a right to use their purchasing power as they see fit. And individuals and society at large would expect the goods to be produced in a certain way at a certain price. Individuals and society would also demand to have their rights for safe health and a safe environment met. Equally, on the responsibility side of things, individuals can use their consumer power to influence and be responsible for the ultimate end decisions, and society will have expectations that need to be met by the companies, consumers, and engineers. From a utilitarian perspective, we can see how the negative consequences on health and the environment detract from the ethical arguments of e-waste. Government is another moral actor in this scenario. A government strives to meet the needs of the different stakeholders involved. This stretches from individuals to businesses and society at large. To weigh up the different needs and wants, they have special tools of influence, control. The government has the right to determine how e-waste is created, how it's processed, where it's processed, and the economic implications of this. Through their power, they can, in fact, influence the whole e-waste process by creating laws. Such laws would be obeyed by engineers, individuals, and different corporations. The government also has the right to enforce said laws. From a responsibility perspective, the government has the duty to ensure that the health of its citizens and the health on which its environment impacts the citizens' lives and the economy is maintained. They also have the responsibility to help ensure that these laws and different systems are actually enforced. They may well have global responsibilities to different actors that stretch beyond their own borders. And from a utilitarian perspective, we can see how e-waste presents a significant problem, as the government not only has the responsibility to decide what is done with all this waste, but also to ensure the health and safety of its citizens and its economy. The most drastic example of this being the 2018 decision by the Chinese government to ban or reduce the import of foreign waste, particularly e-waste, into the country. But we can see how the handling of this will be another ethical problem in and of itself, with nations such as Australia simply shifting the burden of their e-waste onto other poorer nations in Southeast Asia. It's part of reality that engineers will come across, or maybe even design, components that use and produce e-waste. There's a related topic to all this. It's called planned obsolescence. There are different types of obsolescence, and not all of them are bad. Value engineering aims to use as little material as possible to still meet the needs of the user. This balancing of costs and need to keep pace with technological change is actually a really good thing. For example, with mobile phones, if you got a Nokia N95 from 2006, a certain degree of value engineering is a good thing. The phone lasted for 15 years. Now, in 2021, you'd still be using a Nokia N95 and you wouldn't be able to use the new iPhone. Not only would the product be inferior, it would last too long to keep up with technological change, and it would cost way too much. It just doesn't make sense. Functional obsolescence is a different kind of obsolescence, where a generational change in innovation makes the previous item obsolete. For example, one type of functional obsolescence was when the automobile overtook the horse and buggy. The this is a superior product, and it ended up revolutioning the way our society works. The one that we really need to be careful for is pseudo-functional obsolescence, or planned obsolescence. This is when products have a lifetime that is unnecessarily short, or changes are made that really make no sense and don't improve the function of the product. PERC, a US environmental group, give the best example of this as being when companies change charger standards or charger cables from year to year, when in fact there's really no huge advantage for doing so. Cable still charges the phone at much the same rate, it still transfers data, but yet the old cable suddenly doesn't work with the new cable. Therefore, it's been designed by engineers and manufactured by companies to render the previous products obsolete. This creates a huge waste problem in that the previous generation of products need to be disposed of. They're no longer useful, even though they're perfectly functional. Consumers are often particularly unhappy about these changes in pseudo-functional obsolescence, as they are the ones who have to fork out the extra cost to upgrade to the new products when they get no real value in return. Certain products are also designed to have a limited shelf life or be extremely difficult to repair. When this goes beyond the generational changes in technology to today's microprocessors and microchip, this may create a huge waste issue where products are prematurely retired because they can't be repaired, and again, consumers are left to foot the bill. So, we can already begin to see how e-waste and planned obsolescence interact. Planned obsolescence exacerbates all the problems that e-waste brings. The ethical arguments are much the same. So, where do engineers stand in all this, and what should they do? As engineers, we are intimately involved with the processes and design that e-waste generates and is involved in. We also have a responsibility and a role to play in how planned obsolescence is used or excluded when our products and our systems are designed. So, we need to equip ourselves with the knowledge to fully understand the ethical implications of our decisions and actions. We need to be sensitive to the concerns of the public when they say that planned obsolescence unfairly punishes them financially. We need to be aware of the health and environmental consequences for ourselves, our own society, and the global community in the e-waste that our products and systems have in their lifetime. We also need to balance our current needs with the needs of the future generations in promoting sustainability, and e-waste has a role to play. And we also need to be aware of the regulatory and government roles in managing and policing e-waste and planned obsolescence. So, in examining the ethics behind e-waste and planned obsolescence, we've drawn conclusions across society for individuals and for government at large. We've seen the role that engineers have to play in navigating this ethical minefield, and we can refer back to the Engineers Australia Handbook to help us gather some guidance for these challenges. E-waste and the exacerbating conditions of planned obsolescence are wicked problems. They will not be solved easily, they will not be solved by one person, and they will not be solved overnight. But by coming together as a community of global engineers, we can slowly help to improve our society, improve our health, and improve the environment. Hopefully now you've been able to dig deeper and examine the ethical implications of your actions and your role as engineers going forward. Thanks.